One of those moods today. So you know how like some of you pick Concordia for the CS major because we have like no math requirement, right? We like require like introduction to numbers. This week's unit is the number 4. Shut up! I'm venting. Yeah, so we require like introduction to numbers, but so in my undergrad we had you were like stupid to not take a math minor because you only needed one more class. As a CS major, you needed one additional class to get a math minor. They just made you take every class, and that was this class called cosmogony. Not cosmogony. Cosmogony is what Dr. Locklear teaches. What's the name of the class? Combinatorics. Combinatorics is the name of the class we had to take. And I had you can't even pronounce it, right? Yeah, so I had this teacher in there. His name was Samson Adeliki. He brought his own colored chalk. And he was a guy from Africa but had a British accent. And so you go up to the board, and he was just, the subject was impossible, right? It was just really crazy stuff. And he would like talk about it like it was like so much fun, kind of like I think I do with like programming and stuff. So it's like we'd have trouble with the homework assignment. He'd draw a little stick figure up there. Says, right here, this is Mary. Mary was a very diligent teacher. Oh, you found him, Samson Adeliki? Where's he at now? Western?
Yeah.
Yeah, he was very, very diligent. He was a very diligent student. If she would try a problem and it didn't work, she'd rub it off. Try again. That guy was crazy. I loved him. He was great. Yeah, I mean, guy was legit.
Yeah, like that.
Yeah, guy was legit, but it was that class was crazy. So like, it's very interesting how like the CS major required math that nobody would need to do. Well, that's actually not fair. If you're in like a lot of research theoretical stuff, graph theory, combinatorics, a lot of graph theory and statistics type stuff. So it's actually kind of very useful for that branch of, let's say, computer science, but it's not really an applied business branch of CS. So, but it's interesting how they had all those math requirements, and we have like intro to numbers.
Yeah.
So I always found that interesting. All right, so now, how many of you know what kind of processors are inside of your laptops or computers? Okay, how many of you have an Intel processor? How many of you have an AMD processor? All right, so those of you who have an AMD processor, like you didn't raise your hand, but you have an AMD processor. Yeah. So here, we'll connect it to our Android lesson. Did you have issues getting your emulator running? Yeah, were you able to fix it? Oh, okay. Yeah, so if you have if you have a laptop or a desktop with an AMD processor in it, there's a tool. Shut up!
Sorry, I was talking about the situation. His processor. I'm sorry, sir.
Okay, so there's this program some of you may have seen pop up, and what probably failed in yours was something called Haxm, right? So HAXM. It's an Intel product for increasing the speed of the emulator launch. So when Android emulator first came out, it took somewhere between 45 minutes and a week to launch. So usually I would recommend to people, once it launched, keep it open, right? Don't shut it down. Haxm has greatly improved that, and then also but it does require an Intel processor. So it's built on top of Intel technology, because effectively what it does is it allows the Android emulator to run right directly on your Intel hardware. Now, some AMD processors have a virtualization setting in the BIOS. So if you go to your BIOS here, let's see if I can just look it up here real quick. Haxm AMD BIOS. Here, I'm going to restore my pages. That way I get my tabs back. Oh, I forgot I closed a bunch of tabs yesterday. Isn't that sad? I know, it's terrible.
He only has 19 more time.
Let's see if it gives me the name of it in here. It looks like there's this thing called Genymotion that might work on AMD as well. I've never used that, so you might look at that. But anyways, where's the exact setting? Okay, maybe it's called different things on different machines, but basically you want to go into your BIOS on your AMD laptop, which usually, you press like F10 or press escape, something like that when it first boots up, and that gets you into the BIOS, which is a kind of a very small operating system that runs, it's all command line, and in there will be a setting somewhere for virtualization. You want to make sure that's enabled. If it's already enabled and Haxum's not working, your AMD processor's too old. It's not going to work. But if it's not enabled and you enable it, what that will hopefully do is it'll allow your AMD processor to pretend to be an Intel processor in the right ways for Haxum to work. It'll still run slower than it would in Intel, but it will run. And it runs fast enough. I've seen it feel like it runs just as fast. But that's kind of what that Haxum thing is. Now, having said that, if you're on an AMD machine, you can still use the emulator. You just have to use an OS image that doesn't use Haxum. So you have to click on, here, let me just go into Android Studio and I'll show you. And then I'll finish yelling at you about other things. But since we were talking about processors and this is related and your incompetence was helpful, I figured we'd bring it up. So thank you. I got you back. All right, so I'll go into AVD Manager here. Actually, I could have gone into SDK Manager because it's actually the same. Is this going to let me do it? That's not the way I want to show it to you. I want to show it to you in the AVD Manager because that's how you'll see it. All right, so I'm going to go in here like I'm going to create a new virtual device and pick a device. I like to pick Pixel or Pixel 2, something like that, for no good reason. Otherwise, they look reasonable on the screen. If you have a much smaller screen, you might want to pick something smaller, but whatever. So maybe Nexus or something if you have a small laptop screen. Go to next. So here is where we get into the system images. All these recommended images, these are all going to have Haxum enabled on them. So let's see, is it in the x86? Yeah, so you'll click on other images. Oh, see, now let's see. Android non-Haxum image. Okay, got it. All right, so we are going to go to other images here. and you want to choose one of these that says ARM on it. So ARM is a reduced instruction set type of processor. It is not an Intel-based processor. So inside of our actual mobile devices, we really do have an ARM processor in here. But Haxum basically has an Android image that runs on Intel, which obviously your processor inside your laptop is going to be significantly faster than the processors inside of our, or significantly more capable than the processors inside of our smartphones. But the idea is that to get our emulator to run really quickly, it has mapped the Android OS to our Intel processors. But that is done through this thing called Haxum, which does that conversion, okay? If you can't run Haxum, what you'll need to do is you'll need to choose an image that is one of these ARM ones. So let's see, I would probably choose, how new does it go? Because you only need to get API 17 or better. So it actually probably doesn't matter which one you get. So maybe choose something like, I already have ARM Marshmallow here installed. So here, I'm just going to select that. So this is ARM EABI V7A. I don't know what all those different pieces mean, but it's an ARM-based image. And this is for API level 23, so it's not one of the newest ones. But if you remember when we first create a project, what did it choose? API level 15, and that hit the 100% of all Android devices. All right, so I'll just choose this Marshmallow one for this guy. And I'm just going to name it Pixel 2 API 23 ARM and hit finish. And now when I launch that guy, presumably it should launch slower, but I have a pretty quick computer, so it's possible it'll launch substantially faster on here than it might on yours. But this should be using non-Haxum. So this will get you functional on your machines. All right, that makes sense? If you remember from last class, my emulator would have already been up and already started the application and things like that. All right, questions on that? But my recommendation for you, though, is after you have it launched, leave it open, shut your laptop lid when you go off. Just that application is something that runs on your computer until you reboot, then launch it again. Because it will be, once it's loaded, it's pretty usable when you go to actually launch an application. It's not too sluggish then. It's really the launching of the OS that takes a long time, as you're seeing. Because what we're doing here is my computer is emulating an ARM architecture. So when you take CSC250, our computer organization architecture class, and we do talk about assembly language, we learn about the difference between open architecture and reduced instruction set. So basically Intel versus what's inside of our smartphones. And I'm using software to emulate an ARM processor now. And it hasn't been updated in several years because they've come up with a better way through Haxum to do this. Make some sense? All right, so pick your poison, but if you are on an AMD-based machine and it's screaming at you about Haxum, path of least resistance would be if you have a physical Android device. If you run Android, you can just plug it into the USB on your machine. You need to go into your Android device and enable, USB debugging. It's developer mode, so look up your phone on the internet and just say, enable developer mode, because sometimes you have to go onto a weird screen and press a button 9 times and stuff like that, really weird ways of enabling that so you don't accidentally turn it on. But that enables your device to plug in through USB to work with Android Studio. Okay, so if you happen to have an Android device, or you have you can get your hands on an older device, even if you get one off eBay, just something that's API 15 or newer. You might be able to pick up one of those for It's $10 or something, something that old that just turns on. You can use that as your emulator, a real device, and that'll run fast. Otherwise, this is your option.
You just answered my question.
Oh, which part?
Would it run, would it run faster if I got an Android device than?
No. Well, actually, if you have a newer Android device, probably.
Okay.
Yeah, I mean, I'm almost guaranteeing this would run faster than my emulator on here. But my emulator on here seems to run almost instantaneously. Yeah. So it's at that point, if you're happy with the speed for development, that's the most convenient. But before you release something on an app store, you probably want to run it on a real device because the emulators they're very good for development. But every now and then there might be something funky when you get it onto an actual device, especially if you're using things like accelerometers and stuff like that, which are going to be really difficult to emulate. All right, that makes some sense. All right, so we're seeing here how long this is taking to launch. Okay, and this is on an 8-core i9 processor, which is made by Intel, by the way. Yeah, so it's all right. So I mean, I'm going out on a limb here. Chances somebody might have a better machine, but this is a pretty beefy machine, and it's taking that long to launch the emulator. So once it launches, leave it open. Got it? Okie dokie. Otherwise, you can use our Mac Lab down there, but it appears like they just imaged them. So I guess Android Studio is not on them. I'll get it loaded on there. Xcode is on there if you want to do iOS stuff. The Mac side, okay. So that's what I told you. Okay, yeah. So the Windows, so you were on the Windows side originally because you didn't reply to that last statement, the last thing I had messaged. So okay. So you were able to do it, but you had to do it on the Mac side.
Yeah.
Okay, got it. Then we're good. So all else fails, go to our Macs down there, log into the Macintosh side with your CUWS account, just like you would in any other lab on campus, and you can use Android Studio on there. Yeah. All right. So I'm going to abandon this, if that's okay with everybody. Okay. And we'll see here if I go here. What's my latest, greatest? Well, here, I'll just create do I have a new virtual device somewhere? This is API 27. This one's okay. So just hit play on that. There we go. so launched a little bit. It's a little bit better. And what's really, if you saw the little warning I had to dismiss, this guy couldn't use I think I need the latest version for it to use it. Couldn't use my Vega GPU to actually drive it. Because then I think the thing would just be on. You just hit it. It's just on. So, I mean, this whole waiting 4 seconds thing is, I mean, it's really like using your laptop is what we come down to. Yeah. All right. So, first of all, now here's my quick rant and then we'll go on to this thing. Now, we're technology majors in here, right? So, a lot of it, how many of you are CS majors? Okay, most of you. How many of you are IT majors? Okay, a couple of you. Okay. Now, really, some of this I might even say is more important for an IT major, but I think we would just say that it goes across the board. As technology experts, we should know more than the Best Buy folks, right? Or at least as much as the good Best Buy person. How many of you have internet at home? Okay. How many of you know what the speed of your internet is? See, very slow doesn't, so when you buy internet, you buy it at different speeds, right? And even if you're not the one paying the bill, as a technology person, you should know what kind of internet you have. How many of you have DSL at home versus cable? How many of you have cable modem at home? Okay, we have 2.5 people with cable modem. How many of you have DSL? Okay, so you have satellite-based. So a lot more people. How many people have satellite-based internet? All right, so what's the rest of you? Lots of hands didn't come up, or is that I don't know what kind of internet I have? Falls into that category? Okay, so let's roll back. One more statement. Not only should you know how fast your internet is, you should know what kind of internet you have, because that is very telling. If you have DSL, which is what you would have if you go through a phone company like Verizon or AT&T, okay, that is going to have a much slower high-end speed. So usually the fastest you're going to get off DSL, AT&T might try to sell 24 megabit per second, but chances are you need to be really close to their DSLAM in order to get that speed. So you're probably looking at 18 megabits per second is probably your maximum DSL speed. If you're on a cable modem, you can get gigabit speed now, but pretty common if you get like internet, it's like 200 megabits per second. So their budget pleaser internet is usually 200 megabits per second, as opposed to 18 megabits per second on DSL, which is their super premium, faster than light internet.
I think 200 is like common. I think that's not
For cable, yeah, 200. Yeah, if you can't buy slower than 200 in the Milwaukee area.
Oh, in Appleton it's like 50 up, 50 down. But like,
Probably not anymore. Who's the provider? Are we talking outskirts?
Charter.
Oh, Charter is going to have at least 100. Yeah, Spectrum had 100 about a year and a half ago, something like that. Then they just changed that to 200. But yeah, but even if it's 50, it's still way faster. But 100's really the slowest. You know, non-hillbilly cable modems are going to have.
Yeah, I've killed it because I don't even have one megabit.
You probably actually do.
Like when I run it, it just says like 700 kilobits per second.
When you're doing a speed test?
Yep. It's terrible.
Yeah, it's pretty garbage.
Yeah, I know.
You might want to move into like a tent city closer to town. Just kind of park it near a
We had to
Starbucks and use their Wi-Fi.
We had to pay 30 grand just to get like electrical poles up in our place. I'm serious.
Why didn't you just move?
My whole family wanted to live in the country. They have
Yeah,
40 acres.
yeah. I can't necessarily argue. My brother's the same way. My brother's lives out in the boonies and has this giant mansion out there and just loves it. They have beef cattle wandering their land, and so
He's a mechanical engineer though. He drives to Appleton every day.
yeah. No, I get it. I get it.
Crazy.
He just likes when he needs to do something with tech. He just drives. He's a half hour from like a
Exactly.
humanity. He goes there. All right. So first of all, as technology majors, which presumably means we're technology people, right? Otherwise, you might maybe switch majors. Okay, if you don't know how internet comes to your house, that's something you should be interested in as a technology major. Otherwise, I question, why are you a technology major? It's something we rely on every single day. We should kind of know how it works, right? So you should know what type of internet you have: DSL versus cable modem versus not internet. You should know the difference between upload download speed as well as latency. Okay, so typically with satellite-based internet like you have at home, your upload download speed isn't necessarily the problem. It's going to be slower, but usually you can get something at least 3 megabits per second. Yeah, the latency is what's slow. So playing any sort of real-time video game is off limits. Yep. You're going to be at about 5 to 8 seconds per move. So that would be 5,000 to 8,000 millisecond ping. Bad. Yeah, you're not winning any first-person shooter competitions with that. Okay, unless you just go savant mode and you're like predicting 8 seconds ahead. I'm just so good at FPS that I actually artificially limit myself. I'm at a 4-minute delay at this point. I still can't lose. Now, what's funny is a 4-minute delay, you might not be able to lose to me. I am so bad at those games. It's really funny. I feel like I could get decent at them, but I feel as poor as I am at them to begin with. Even if I worked really hard at it, I feel like my maximum level would be like low end of okay. There's just something about it. But like World of Warcraft, things like that, I'm good at it. I'm good at those, except not PvP.
See, not everyone can be good at World of Warcraft, though. Just saying. I feel like there's more to manage when you play that.
Yeah, I don't know. Maybe it's too quick. Too much stuff's happening for me. Okay, so you should know what kind of internet's coming to your house. You should know what speed internet you have. DSL is almost always slower, and it's not because AT&T is a jerk. or Verizon's being a jerk. It's because the technology that's based on digital subscriber lines are actually running over the same physical lines as dial-up modems used to run over. It's running over copper telephone lines called POTS, plain old telephone. Plain old telephone service is a POTS network. All right, so instead of sending an analog signal over a POTS network, it's sending a digital signal over that network. All right, that's why you had a modem. You know, a modem converts from analog to digital. So when you had a dial-up modem for internet, you were talking to a digital computer somewhere over an analog highway to a digital computer. You needed modems on both sides that would convert from the analog to digital and then convert from digital back to analog to send it over the center thing. Which then becomes the funny thing today, because if you have a little box at your house for DSL or cable, they call it a cable modem or a DSL modem, which is actually just kind of something left over from the early days of the internet, because it's not actually a modem. It's not having to convert between analog and modem. Stands for modulator demodulator. It doesn't have to convert between analog and digital because it's all digital at that point. So the difference in the early days between DSL and cable was this idea that DSL was dedicated bandwidth. So if you got 18 megabits per second, which I mean, early days of DSL, you would get like, well, way less than 1 megabit, but let's say relatively early days of DSL, you would get like 1.5 megabits per second. All right. But the idea was like it was dedicated versus like 20 megabits per second for cable modems at the time, which was shared. So if you lived in a neighborhood with 50 other people who were all using the cable modem, your speed would go way down, was the idea. Where DSL was dedicated. But what they didn't tell you was that phone companies use the airline and the hotel booking mentality, where they oversold their bandwidth. So hotels usually book about 10% more rooms than they have, or are willing to book that with the expectation they're going to have no-shows. Same thing with airlines. That's why sometimes they look for volunteers. It's not always because I stole one of the seats. I love that, though. When a flight wasn't looking for a volunteer, and then all of a sudden I get my extra seat, and then it says, now looking for a volunteer. Because it's like my good deed for the day. Somebody's getting a free flight plus a voucher for a future flight. It's a gift. My obesity gave somebody a gift. It's all how you spin it. It's all how you spin it. All right. So what would happen is like the phone companies, they would oversell their bandwidth. So even though it was dedicated, if everybody who had purchased DSL was all on at one time, they wouldn't get the full bandwidth anyways. All right. So two different technologies. If you can get cable modem service today, buy cable modem service over DSL 100% of the time. The only argument for getting DSL today is if you have television service or whatever with that same provider and just the price difference is too good to pass up type thing. Because it's not like 18 megabit per second DSL at home is unusable, right? And now, like AT&T, for instance, down in Milwaukee, and it's about to come to Mequon, they now have a new technology which is fiber-based. It's no longer a DSL technology, so they can do gigabit now. So it's kind of a new type of technology. But anyways, as technology majors, we should know the type of internet we have. We should know our theoretical minimum maximum speed. All right. We should also know what that means. If we have 200 megabits per second, what does that ultimately mean? Remember from last semester, we did the conversion stuff. So 200 megabits per second divided by 8 means I have a theoretical maximum download speed of 25 megabytes per second. And what do the commercials do? They always call it 200 meg. It's a bigger number. 200 megabytes. I remember the old days at Best Buy, they would give the size of hard drives in bits. You just look at it and think it was in scientific notation. 1,450 billion bit hard drive. Well, how old is all relative? So let's. This is probably a bet. This would have been from I don't know, early 2000s. 2000,
And there was swap. Then there may be some YouTube videos.
certainly late 90s.
Best Buy commercial video. I can find that.
So like 97, 98. I mean, at that point you were, 1 gigabyte hard drive was huge in 1997. Yeah, I mean, at that point they were still selling 5 1/4 inch hard drives instead of 3.5 inch hard drives. And now we have the 2.5 inch hard drives, and now solid state drives for, laptops had the 2.5 inch mechanical drives in them. And then they had a 1 point. Then Apple, had their a 1.8 or 1.7 inch hard drive in their original iPods. That was a mechanical hard drive in those. So, whatever. All right, so technologists, know your internet. Know the technology that's in your life. Okay, look down at your laptop. Know what that is. You should know screen size, resolution, kind of processor that's in it, amount of RAM that you have. Okay. As a technology major, it's not just, oh, this is my computer, it's used. It might be a junky computer, but it's your junky computer, right? Know what's in it. Because you're the type of person that should know what's in it. Because you're going to be the one that your relatives are going to call upon and say, oh, I'm in the market for a new laptop and whatever. And he's just going to say, yeah, just get a used one, a couple $100 is fine. It's like, well, I found a $200 toaster with a screen. Yeah, that'll probably work. I mean, it's got a screen, got a USB port. You probably hook a keyboard. RGB. Yeah. So take some pride in being a technologist and understand the technology that's in your life, right? Cell phone, know your screen size, know, processor specs, that kind of stuff. Plus, it'll help you learn about how different things compare to each other. All right. Everybody get all that?
Yeah.
Okay, so at some point, there may be a pop quiz where I tell you to tell me some information about those things, which means that if you're not convincing on that quiz, I might ask to see your machine to confirm your answer, because I'll get different answers, right? Okay, I can almost promise that I'm not trusting Clancy. Look, I have a 14 million gigawatt. I got 14 million gigawatt keyboard.
It's true. Speaks the truth.
All right. Oh, you see my fully articulated 3D printed skeleton here?
What's his name?
Well, we're actually going to do it now that this printed out well. I'm gonna take the skull. I'm gonna go home and I'm gonna figure out what it is relative to Mr. Gonzalez, and we're gonna scale everything up, and we're gonna have Mr. Gonzalez's skeleton.
How's he doing?
But this, he's doing all right. He's in a zero oxygen environment, but he survived. Yeah, he had 2 different sanitary washes in boiling water or something, and then he was 2 different maximum heat setting dryer things. He was also in 200-degree water for 4 hours in a bag. We had to put a brick in the bag to get it to sink. So he spent time in there with a brick. And now he's all dried out, but now he's in a zero oxygen thing, but he's got Ollie and Caesar looking after him. It's his honey badger and hammerhead shark.
Oh.
Hammerhead shark's his best friend. He was the best man in the wedding.
Okay.
Ollie's his pet honey badger.
Yeah, obviously.
Yeah.
No, these are actual real stuffed animals. This backstory is all accurate. Go ahead.
So just to clarify, there might be a quiz on our computer.
There's always possibly a quiz. Any possible day, I might give a pop quiz. It's right there in the syllabus. I'm just telling you this is an important enough subject that starting next class, there is a risk that I'm going to ask you to tell me about your technology that's in your life, and you should know it.
Okay. What is the
Makes
percentage
sense?
of that risk? Is
Yeah.
it like 80-20, like 90-10?
105%?
Ask about it, the worse it probably is. More likely.
I would say it's 100% risk it'll happen eventually. One day I'm going to walk in and I'm going to just say, oh, good day for a quiz. And we're going to just do it. All right? So, let's do some Android stuff.
Yeah.
So last time we were talking about the basics of, well, last time we talked about the exam, but then time before that we were talking about the basics of Android, right? And we talked about Android being this collection of, so it's written in Java. We use Android Studio. Android Studio is an example of an IDE, so it's like the version of Eclipse that we use for writing Android applications. We talked about the idea of design patterns. We talked about a specific design pattern called Model View Controller, which we're going to look at a little bit more today, because Model View Controller says it's a good idea to keep your data separated from your visual interface, separated from your logic, right? Keep those guys in different places and then somehow magically connect them. All right. Now, the idea here would be is MVC is an idea, not an implementation. So the way that Android implements MVC is going to be different, similar, because they're solving the same problem, but potentially different than the way like Xcode for writing iOS, iPhone software does it, which might be potentially different to how Visual Studio for writing .NET applications does it. But all three of those implement this idea of your interface lives in one place, your logic controller lives in another place, and then your data lives in another place, and it brings all those three things together so you can write your code in terms of your interface and in terms of your data. Make sense? All right, so we're going to be exploring today how this is done in Android Studio. Well, how it's done in Android and how Android Studio exposes that to us. All right. So here is kind of the idea of an Android application. So this kind of shows a single screen in an Android application. We have something called an activity. That's our controller. We have our layout, which is our interface. That's what we see, that kind of interface. And then our database is going to be the model. We will work with databases, but not yet. So right now we're just focusing on these two. So right now, what you have in your thing is a interface that says hello world on it, and you have a controller that was created for you that you haven't touched, right? But it does exist. All right. So let's go and look at, and then I talked to you about this thing called Gradle, because sometimes you'll see, Gradle building or something like that, or sometimes you get a little warning that says Gradle needs update. Should you update it? Gradle updates go fairly quickly, so you can probably do that at any point in time. But Gradle is like this magical build tool. It used to be called Ant before that. But what it does is it takes all of these extraneous files and compiles them together in the smart way so that your application works. Let's not go any deeper into it than that. Its old ancestor from the old days of compiling your own code in C with something called gzip tars or tarballs is what they would be called, was a program called Make. Right? So it's called Gradle. You're going to see that word referenced sometimes. You won't have to work with it anytime soon. At some point, if you're writing professional level Android stuff, you might tweak Gradle settings if you wanted to build differently for different size devices or something like that. Go ahead.
Is Gradle used in like a lot of IDEs or
Java-based stuff?
Java-based stuff?
Yep.
Okay.
Yeah, it's in fact probably all Java-based stuff. Okay. So let's get to it in here. So here is my, let me shrink this down and let me shrink that down. All right, so here's my current interface here, right? And so this is my layout, and this guy is called activity_main.xml. How many of you have heard of XML before? What is XML? Okay, well, first of all, what several of you are searching for is what does it stand for? Kind of meaningless, but this stands for Extensible Markup Language. All right, and what is this really? This is a data representation language modeled after HTML, so that means it's tag-based, for representing, well, let's just leave it like that. So for example, if I wanted to represent a person, I can say person name Mike so that is an XML representation of a person that has a name. If I also want to give this guy an age, I can throw age inside of there. So this guy is going to look a lot like, I'll explode it out here. It might be a little easier for you to visualize. So this looks, if you've done some HTML before, this looks a lot like HTML. You have an opening tag, you have a closing tag. Opening tag, closing tag. Opening tag, closing tag. Just instead of being the standard HTML things you are used to seeing, you know, HTML, body, H1, table, TR, TD, things like that. It's things that mean something for marking up your data. Make sense? Okay. So XML is a tag-based idea for describing your data this way. And your data can look however you want it to look. So the good people at Google or whoever came up with the standard for how our interfaces are built for Android, they came up with a representation of things. So for instance, there's probably something in there called like, well, actually I could show you. So if you look in Android Studio here, down here at the bottom left, it says design. Then it has one that's called text.
Yeah.
Here is the XML. So we have something called a text view. And so if you've done HTML before, you could actually have an opening and closing tag all in one by just putting a slash there at the end of it, because the tags in here actually use a whole bunch of attributes instead of text in between. So this is a text view tag that has a width, a height, some text that's equal to hello world. If I change this guy in here to be LOL, and then go back out to design, you'll see now it says LOL. Okay, then it has some constraints associated with it, which we're not going to mess with. All right, so this is the XML that's behind the scenes. Every now and then you'll have to come in here and tweak this, because the drag and drop stuff might not quite let you accomplish exactly what you wanted to accomplish, but let's call it good enough. Go ahead.
So could you also, for solving the whole world problem, I use the string method thing that's located in.
Yeah. You use this in the resources, the strings.xml and the resources thing.
Yeah.
At some point, we'll talk about that.
Okay, and I was wondering, like, well, if that's the case.
That's mainly used for dealing with different languages, or having the same label throughout your application. You can set it to a string and then change what's in there, and it'll just update everywhere.
Okay.
Okay. So in any case, that's what our interface is built out of. It's something called activity-main.xml, and that's what it looks like behind the scenes. From our perspective, we don't necessarily care. This is just Android Studio's way of describing interfaces, and our layout interpreter thing here shows us what the visual version of that is. Yeah.
Could you change the font or size of it?
Yeah. So the way to actually do that easily is if I select something here, I can come over and go to text size. So over here on the right, we have our attributes. So I can go to text size here and let's just bump it to 36. And then, there's all sorts of other things in there for changing stuff. We won't get too fancy with look and feel and stuff like that in here, but you can get as fancy as you want with your stuff. Okay. Now, this guy, if I go up here to ID, this default guy doesn't actually have a name because we're not connecting to it with our code yet. So remember, MVC says keep your interface and your logic separate. We'll deal with data later, but at least our interface and our logic are in two separate places. I want to have some way of programmatically changing this text, which means I have to have a way in code. So here's my activity file here. I have to have some way in here I want to change the text on the label. That's what I want to be able to do. How do I get access to the label in Android MVC? Okay, so the first thing we need to do is we need to associate a variable name with our label. So we're going to come out here, we're going to click on our label, and up here where it says ID, I'm going to call this guy my label. So now he has a variable name associated with it. And if I go and I look at the text behind the scenes here, notice that he now has an ID called my label. Okay. So now what I can do is I can come into my code and I'm going to say, this guy's actually, let me just show you real quick. I keep calling it a label. He's actually something called a text view. So, yeah, so up here in the upper right, I don't know if you can see that on the screen here, but it says text view. That's the kind of animal he is. He's not a button, he's a text view. Okay, so I'm going to come into my logic here, and I'm going to say, I want to create a text view, and it'll import it for me. I'll call this guy, I'll call it my, I'll call it my label just because that's the guy it's representing. And he's going to be equal to, now what I'm going to do is I'm going to ask this activity. So this guy is my main activity, he's something that is a app compat activity. You don't have to worry about it other than the idea that he's an activity. He's our logic part of our screen. And this activity is associated with that layout activity main, our design. That's how those two get glued together. If I were writing this, I probably would have said this dot set content view there, because I like to be explicit with that, but the default that it puts in there, it leaves the this off. That's fine. All right. So this is where this activity gets married to this layout. Make sense? Now, since this activity knows about that layout, I can now ask this activity to find things in that layout. So I can say this dot find view by ID. And then we have this special class that gets generated for us automatically called R. So I'm going to say R dot ID dot my label. Okay, so I'm asking, so that's how an object refers to itself from within itself, right? Nothing new there. I'm asking this activity to find a view, given an ID, and the ID of that guy is called r.id.whatever I named my widget. Okay, and it fills in for you. So as I started typing r.id.my, it showed me what was available. Okay, so now I have access to that label in code. So I can say my label dot set text to woot. All right, and this all happens inside of something called onCreate. We're going to be talking about the life cycle of an activity sooner rather than later, but at least for us right now, onCreate happens before you see the app on the screen. All right, so even though in here I've designed my label to have LOL in it, that's going to programmatically get changed to woot before it shows up on the screen. So I'll actually never see the LOL when I run this because of where I put this logic. So there's onCreate, there's things where it's already on the screen, where it's about to come onto the screen, when we come back to the screen, all sorts of different points in which we can interject logic with the life cycle of an activity. Yep.
It's like the main method for.
Yeah, you could say that. Yeah, I mean, don't make a direct comparison to that, because there is a main method somewhere way behind the scenes here that was created for us that Gradle takes care of us. this is what happens before a screen shows up. It lets us visually see. All right. So if I were to go and run this now, I should see Woot on my screen. Now, when you run, it doesn't necessarily automatically pop your emulator up for you, so you might have to switch over to your emulator. And there's my Woot. Now, if I comment out this line and choose not to set the text, I'm still gaining access to that label. Now you see it says LOL. Now you see it says LOL. That makes sense? All right, so now what we might want to do is we might want to have a button that only when we click the button does the text actually change. Right? That way we can see the whole action. So we're learning a couple of the primitive type go-to moves we might want to have for our Android application. Because one thing I want to emphasize here is the second 8 weeks, we are going to be learning more programming knowledge in the context of Android development. We're not going to become experts in Android development. If you want to go off and do tutorials and stuff like that to learn all the fancy widgets and things, you can. But we've just upgraded our user interface, so I'm going to be showing you very basic ways of interfacing. Enter some text, click a button, have something happen. That kind of stuff. All right? So, don't expect to be... You will be able to launch functional things on the App Store when we're done, but probably not very pretty things. Okay? So, one thing that I always do, and I'm not necessarily recommending this, well, I sort of am, but modern day interface builders it's been this way for Android for a while. Well, actually, before we had constraints, you actually had to build a different interface for the different types of and screen sizes you had for Android. So Apple used to always say that, Android sucks because there's 4 million different screen sizes. Right, 4 million different pixel densities, all this stuff, because there's so many different Android devices out there, because Android is solving the Microsoft problem where they're writing an operating system that runs on all sorts of hardware. Where Apple is solving the old Apple problem where they're writing an operating system, iOS, that runs on only their own hardware. And Apple used to be able to brag because all of the iPhones were the identical size. Every new one that came out was the identical size. Once they introduced the Retina screen, it was still the same physical size. You just had double pixel density. So you didn't have to change your interface design at all. You would just use higher quality textures and they would scale down for the better looks. But now, there's all sorts of different size iOS devices, right? So across the iPhone line, we have probably over the history of iPhone, 6 or 7 different sizes. And then you throw iPads in there, and you probably have 6 or 7 different sizes in there as well, with the the iPad Pros and the Minis and the whatevers. So, is it as bad as Android? No, but you don't hear Apple yelling anymore about how Android's fragmented and Apple's not. They both have some problems with different screen sizes, and when you develop for that, you kind of have to take that into consideration. You might download an app from the App Store if you have one of the jumbo iPhones or one of the jumbo Android devices. Your app might look a little funky on your device when it looks better on somebody who has more of a standard size device because maybe it was designed for that and now it's stretched out on your device, right? Especially since this is a Note 10 Plus. This guy tends to be not necessarily wider than most devices. It's a lot taller. Where if you have another device, another device tends to be not quite as tall, but maybe a lot wider, and they're calling that like the jumbo phone. Maybe it holds the aspect ratio a little bit better, something like that. So you might have apps that look a little different on different ones. Yeah.
Kind of off topic, but why did you switch to an Android?
I switched. This is my third note. It was when the first iPhone 10 came out, and they were bragging about the Animojis, and that didn't do anything for me. But I probably would have still gotten it, but the issue was that I was going to have to wait. I always get a new phone every single year, and I was going to have to wait 2 extra months to get the upgraded phone that I wasn't even all that excited about when I could have gotten a phone with pretty similar hardware that day.
Yeah.
My wife's still an iPhone user, so I developed for both, so we have both of them in the family now. But now I've gotten used to the Android stuff, and you can do some things you can't necessarily accomplish on an iPhone on there that, I don't know, I like better, even though I would say the ultimate ecosystem of iPhone is superior.
Okay.
It just works. Where, I mean, like I have my phone set up to automatically reboot every single night overnight, just so I get a nice clean run. But works fine. I like the giant screen. I do a lot of YouTube video watching and stuff on my phone, so the giant screen seems to be helpful. But anyways, here's my go-to move. And if you talk to a professional Android developer today, I don't build any of my interfaces. I'm a coder. All right, so they're going to say this is stupid. But this is how I build my interfaces. I've done this for years and years and years, and it lets you build utility apps very easily. I go ahead and where you have this constraint layout thing over here, I'm going to right-click on this, and I am going to say Convert View. And I'm going to make this guy a linear layout. Linear layouts come in two flavors. Two flavors. Horizontal and vertical. With a horizontal linear layout, anything we drop in there gets lined up automatically horizontally. With a vertical, anything we drop in there gets lined up vertically. All right, so the default for this guy, it says horizontal. I'm going to go over here to the right. Orientation actually has not been set for it, so I'm going to make sure I select that linear layout. I'm going to come over here to orientation, and I'm going to select vertical. So I always have my top level thing set up as a vertical linear layout. And now what you'll see here is if I just start dragging buttons in, it'll just stack them on top of each other. Make sense? If I were to make this guy horizontal, now it stacks them next to each other. I promise it's next to each other, but if I click on this button, what do we have? When we have a layout, see where it says layout with? It says match parent. Well, the parent of this button is my horizontal linear layout, which is the width of my screen. If I change this from match parent to wrap content, you'll see he wraps the word button, showing me my next button. I can then tell that guy to wrap content. I can then tell that guy to wrap content. See how that's working?
Yeah.
I can keep throwing buttons in there. Okay, so when you click on something, it is that guy's attribute you're messing with. So layout width, layout height, set those appropriately for what you're trying to accomplish. If you want to have a button that spans the entire top of the screen, match parent's fine, right? But when you run into a situation like that where you've dropped 3 things in and you only see one of them, chances are it's because something's matching the parent and pushing the other ones off screen. Make sense? All right. So I'm going to go ahead and just get rid of those buttons real quick. I'm going to click on my linear layout. I'm going to go ahead and turn this guy back into vertical. All right. Then I'm going to give myself a text view. And I'll let that guy go ahead and match parent, because what we want to do here is we're going to mock up what we just had before where we have a text view. It's going to start off with one thing in it. Then I'm going to have a button that when I click that button, it's going to change it. So we can see it happen during real time. So we're going to learn how a button works. I'll go ahead and change the text on this guy to 36 or whatever. Now I'll teach you something else here. You can go down here and find like text orientation type stuff. So here I'll make this bold, that kind of stuff. But we do have this idea in Android called gravity. All right. Now, when you think about gravity in real life, what does gravity do? Okay, so we live inside the planet. Think of the planet as being like a linear layout. Okay, so we live inside of this box, and inside this box there is a gravitational force that is pushing us down. Okay, but what if gravity was pushing us to the left? We would fly towards a wall. If it was pushing us to the right, we'd fly towards the other wall. If gravity somehow magically had the ability to center us, we'd suck to the middle of the planet. Or if you think of this room as our linear layout, we'd all be floating right in the middle of the room. Make sense? So for any container in Android, we can set the gravity. And what that'll do is it will move things around in there. So this text view is a container. So if I click it, and then I scroll down and I find gravity, and it is in, sometimes it's up here in your common ones, but for text view, it's not one of the common ones. And you can accomplish this in a different way, but I just like using gravity for it. Plus, that lets me introduce gravity. So I'm going to go down where it says all attributes, and I'm going to scroll down and find gravity. So here's gravity. And what I'm going to do is I'm just going to go ahead and click center. And you see the guy sucked to the center. Because now he's in a room with weird gravity. Make sense? The default gravity had him sucked to the left. The default gravity for a linear layout has it sucked to the top. So notice the common attributes for a linear layout. I'm going to go ahead and say center. Oh, I haven't applied it. That's the problem. There we go. So now I can have all my stuff centered if that made sense in my app or something like that. Okay. So I'll go ahead and clear that, hit apply. It'll go back up to the top. All right, so we're going to have this guy initially say, usually you can just double click on it and change the text. No, maybe not. So common attributes for a text view has a thing called text. I'm going to set this guy to say LOL. So there's my LOL. All right, now, and if I go ahead and run this application right now, right now it'll be an error because this guy has a ID called text view, and my code here is looking for something called my label. So if I go back in and I just go ahead and rename this guy to my label, you'll see that now this guy's happy again. He was able to find a widget on my screen called my label. So if I run this, I will get my LOL there. Go ahead.
Are you able to set up gravity for so that in a container there's different gravity for different objects?
Yep.
Okay.
Yeah, any container can have its own gravity. So you can have, if we had a text view inside of a room and this room had a gravity to up and the text view had a gravity to center, only within the text view would it be centered. Otherwise, the text view itself would be sucked to the ceiling. Okay, so gravity operates with everything inside of that container. And the closer the container to you, the gravity overrides the guy above him. Okay, so there's my LOL. Now what I want to do is I want to go ahead and give myself a button. So again, I have my vertical linear layout here, so I'll just drag a button in here and it'll show up right below it. And I'll change my text on my button to say, click me. And put a little smiley face on there. Okay. Now, I don't need to give this button an ID. That is to say, a widget only needs to have an ID if I need to gain access to it in my code. Now, if for some reason I wanted to change my the text on my button or something like that programmatically, then I would give it an ID because I'm going to need to actually get that button and start changing his text and things like that. But generally speaking with buttons, we don't need to actually manipulate the button. We just want to be able to respond when that button was clicked. Make sense? All right, so I'm going to go into my code here, and I'm going to write a function. Now, this function has to be written this way. It must be public. You can name it whatever you want. So I'm going to call this guy on click me button pressed, whatever. Name it whatever you want, but pretty descriptive, right? Now he must take a view as a parameter. I'm not going to tell you why right now just for time, but just he has to take a view as a parameter, and we'll just call it view v. You can name it whatever you want. And sorry, this guy must return void. So you have to have a method that's public, returns nothing. You can name it whatever you want, and it has to take a view as a parameter. And what we're going to do in here is we're going to go ahead and we're going to gain access. I'll just grab my text view in here. So when I click that button, we'll go ahead and grab our label, and I'm going to set the label to Woot. But this is only going to happen when I click that button. Make sense?
Yeah.
Now again, I'm going to remind you about MVC. MVC Model View Controller says keep your logic, which is what we're dealing with right here. This is our controller. Our logic is here. Keep that separate from your interface. So if I go and run this right now, says LOL, I can click that button a zillion times. Nothing happens. This is my interface. I have not let my interface know. I haven't connected him to that function I just wrote. Because right now they're separate. So I need to go in and I need to take advantage of Android's MVC to glue these together. So because I've written this function to be public and void and had him take a view in as a parameter, over here, when I click on my button, he has an attribute called onClick. Under common attributes, if I hit the drop-down thing, notice how it found my onClick me button pressed. If I click that guy now, then I rerun my program. Now it runs that code. Go ahead.
How do you get to the area in Android Studio where you see the screen like that what you're on right now?
You would go, so if you're in your project, go to App, go to Resource, RES, go to Layout, and then double click on the layout you're messing with. Right now you just have one called Activity_main, and that'll open up the screen. You get it? Okay. All right, that makes sense? Now, if you want to mess around with this a little bit, we can go ahead and we can give ourselves a global variable here. So I can say int count is equal to 0. And then I can set my text here to count. And then I can say count plus plus each time I click. So we'll actually see it'll be count 0, then count 1. That would be woot 0, woot 1, woot 2, woot 3, so on and so forth. Because I gave myself a variable here that is defined inside the class, but outside of onCreate and outside of onClickMe. So this variable is accessible anywhere inside of this class. So now if I run this, there's my woot 0, woot 1, so on and so forth.
Yeah.
That makes sense? All right. So for your homework, we want to upgrade your current project to have a label like you have now, but it's a label that can be changed from code. And change it when you press a button called Click Me. And just for the sake of argument, why don't we go ahead and have it model what mine does, where I have a global variable. You can make your variable be whatever you want it to be, but count makes a lot of sense. That way you can add something to it so you're seeing that this function gets called each and every time that we click that button. So this is kind of reinforcing, you're practicing what I just showed you. You're reinforcing this little widget. So what I'm going to do is I'm going to show you 3 or 4 kind of little go-to moves, and then we're going to build all of our applications the rest of the semester with those moves in mind. All right, so we have vertical linear layouts. We could put horizontal linear layouts inside of vertical linear layouts. So if I want to have 3 buttons across from each other, but inside of stuff that stacks, so I build all my interfaces in terms of vertical and horizontal linear layouts, which gives me very boxy interfaces, but it's easy for me to do, and it gives me kind of utility type applications. All right, makes sense what I'm asking you to do? Write an Android application that has a label, and that label changes to different things every single time you click a button.
Okay.
If you want to mimic exactly what I did, that's fine, but that label should change to something different every time the button clicks. Got it? Questions, comments, concerns, bribes? All right, I will see everybody on Tuesday.